In this video, I'm going to show you how to solve Cauchy Euler Homogeneous linear equation. And the form of this type of equation is, let me write the equation. And this is the form of this equation, this type of equation, and where a naught, a1, an minus 1, comma an are constants. So how to solve this type of equations? So in order to solve this type of equations, we have to reduce the equation. So how to reduce the equation? We need to put x is equal to e to the power z. If you put here x is equal to e to the power z, then it implies, so x is equal to e to the power z means, so what does it mean? It means z is equal to log x base e, right? It means this. Now from here you see dy by dx, it can be written as dy by dz, dz by dx, right? You can write that way. So hope you have understood this. Now from here, from this equation, you can find dz by dx. If you differentiate this with respect to x, then what you will get? 1 by x, right? You will get 1 by x. So here this implies dy by dx is equal to 1 by x dy by dz, right? And it implies x into dy by dx dy by dz, right? So let us write this differential coefficient d by dz, let us denote it by capital D. Then this equation becomes x dy by dx is equal to capital D y. We can write this way. Now let us consider this as equation number 1, and let us consider this is equation number 2. Now you see, let me scroll down the page. So how to reduce d to y by dx to, how to reduce this? So it can be written as ddx of dy by dx, right? And here again, so let us do one thing. Instead of this taking this equation number 2, let us take this one as equation number 2. Let us take this as equation number 2. So from here what you can do, let me clean this first. So now you can see, you can replace this dy by dx by 1 by x dy by dz. Okay, so that's equal to dy by dx of 1 by x dy by dz. Now here what we're going to do, let us consider 1 by x as u, and let us consider dy by dz as v, right? Then let us apply this rule, product rule, derivative of u into v, that is u derivative of v plus v derivative of u. Let us apply this. So now let us consider 1 by x as u and dy by dx as v and apply this rule. So according to that rule, first function, that is 1 by x here, and derivative of second function, that means d by dx of dy by dz. Then second function, that is dy by dz derivative of the first function, that means ddx of 1 by x. Now here you see this part, this d by dx can be written as dz, you can write in this way, d by dz and dot dz by dx, you can write this way, and this part is written this way, of dy by dz. So if you differentiate this term with respect to z, then you will get second order derivative of y with respect to z, then this part should be written here, dz by dx, right? We will get that one. So from this part you can see clearly, from this part we will get this result, and derivative of 1 by x is minus 1 by x square. Okay, so what we have got now, let me clean this part. So finally we have got that is equal to 1 by x dz by dx, dz by dx, second order derivative of y with respect to z, minus, and here you see, sorry, I have made a mistake here, this should be z, dy by dz, okay, right, because second function is dy by dz here. So dy by dz 1 by x square, and this minus here you can see it comes from here, because derivative of 1 by x is minus 1 by x square, right? So hope you have understood this. Now let me scroll down the piece. So here again you can see this dz by dx can be replaced by 1 by x from equation number 1. So if you do so, then what you will get, so here you can see this is 1 by x. If you replace this one by 1 by x, and here is also 1 by x, that's going to be 1 by x square. So we will get 1 by x square, second order derivative of y with respect to z, then minus dy by dz, so here 1 by x square. So that's what we will get, right? So now you can take the 1 by x square common, right? One by x square is taken common, then you can write d square minus dy. So d means it is the coefficient, differential coefficient d by dz, right? So if you replace that coefficient by capital D, then you will get this one. So from here also you can take d common, right? Then it becomes x square, and here d into d minus 1 y. So here you have got x dy by dx is equal to dy, then x square second order derivative of y with respect to x is this. Then similarly what you will get, similarly, let me minimize this piece. Okay, so similarly you will get x cube third order derivative of y with respect to x will be equal to d into d minus 1 into d minus 2 y, and so on. And if you continue that, then the n term will be that's going to be, here you see this term x to the power n, the general term. Let me write a general term here, nth order derivative of y with respect to x, then you're gonna have d into d minus 1 d minus 2 and dot 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 dot. At the end you will get d minus, so you will get n minus 1. So here you see, when you have third order derivative, so at the end d minus 2 we have, so for nth order derivative there, that must be n minus 1, right? So hope you have understood this. So now if you remove this bracket, then it's become, so what will it become? So it will be, let me write it directly, so it's going to be n plus 1 after removing this bracket. So then y. So this is what we have got, right? So we can reduce this homogeneous equation in this way. So after reduction of this equation, putting those things that I have used here, we can solve such type of equations. Let me show you how to solve this kind of equation. Let us take a question here. Now let us solve this equation. How to solve this equation? So here, first let us write the given equation as it is given in the question. So what we're going to do first, so we're going to put x is equal to e to the power z, and which implies that z is equal to log x base e, and also we are going to replace d by dz by capital D, right? So if you do so, and if you apply this, then what you can write? This term can be replaced by this result, right? And this x dy dx, it can be replaced by this result, this one. So what we will get, or you may apply this general form, and then x dy by dx, that's going to be dy, then x square dy by dx2, second order derivative of y with respect to x, that's going to be d into d minus 1 y, right? So if you do so, then what you will get, then this given equation becomes d into d minus 1 y minus 4 dy plus 6y 42. Now as we have considered x is equal to e to the power x, and that's why x to the power 4 will be e to the power 4 z, as we have considered e is nothing but e to the power z, right? X is equal to e to the power z, so x to the power 4 will be e to the power 4z. So now our denominator becomes here e to the power 4z, and directly you can write this way, 42 e to the power minus 4z. That way you can write. So hope you have understood. Now let's scroll down. Okay, so here this can be written as d square minus d minus 4d y, or do one more thing, plus 6 y 42 e to the power minus 4z. So this is what d square minus 5d plus 6y 42 e to the power minus 4z. So here you see this equation, now it is reduced to this form, f of d y is equal to q of x or phi of x, whatever you can take. So this form. So we have solved different type of differential equations of this form. So here you can see this is the q of x in this case, right? And f of d is this, this is here f of d is d square minus 5d plus 6, right? So what will be our auxiliary equation? So let me scroll down. So our auxiliary equation is f of m is equal to 0. So if you replace the d here by m, then you will get m square minus 5m plus 6 is equal to 0. So now let us factorize this. If you solve and factorize this, then you will get m minus 2 into m minus 3. So hope you know the factorization, so I haven't shown here. So therefore m minus 2 is equal to 0, or m minus 3 is equal to 0, which implies that one root will be m1 is 2 and m2 another root is 3. So these are the two distinct roots and they are real. For real and distinct roots, we have already discussed that how to find a CF. CF will be here in this case C1 e to the power m1x. So here m1 is 2, so we will get twice x, then plus C2 e to the power instead of x, what we're going to write here, you see, in this case capital D represents d by dz, not x. That's why here instead of x we will take z, right? We will take z. So if d represents d by dx, then in CF C1 e to the power twice x should be written, otherwise it is z if it is z, right? Hope it is clear. So that's how 3z m2z, this is our CF. So it's clear to you, hope it is clear to you. So this is our CF. Now next task is to find PI, particular integral. So here we know that PI is equal to, if the q of x is e to the power ax, then how to find a qi? That is 1 by f of d e to the power ax, which is equal to 1 by f of a e to the power ax, if f of a is not equal to 0, right? That was the formula that we had used. So if you compare this q of x e to the power ax with the given equation, right hand side of the given equation, here value of a which is minus 4, right? So here value of a, q of x is e to the power 42 e to the power minus a, instead of a minus 4x, so a is equal to minus 4. So f of a, that's going to be f of minus 4. So if you put here in f of d, if you replace the d by minus 4, then what you will get, minus 4 square plus 5, sorry, not plus 5, minus 5 into minus 4 plus 6, and that's going to be 16 plus 20 plus 6, that's going to be 42, which is not equal to 0. Therefore our pi is 1 by f of a q of x. So here f of a is 42 and q of x is 42 e to the power minus 4x, right? So hope you have understood this. Now, sorry, not x, there is z. I have made a mistake here. So in this case we have z, right? Z, not x. So now this 42 gone. So our pi is e to the power minus 4z, e to the power minus 4z, which can be replaced by which can be written as e to the power z whole to the power minus 4, and that is, and e to the power z is nothing but x to the power minus 4 means 1 by x to the power 4. So our solution should be y is equal to, solution is y is equal to CF plus PI, isn't it? CF plus PI. So here we have got the CF. Y is equal to CF is C1 e to the power twice z. So e to the power twice z plus C2 e to the power thrice z plus 1 by 4. Pi is plus 1 by x to the power 4. Right? Now one more thing. E to the power twice z, which can be written as e to the power z whole to the power 2. Right? And e to the power z is nothing but x. So this become x square. So our solution will be y is equal to C1 x square. Similarly, C2, this will be x cube 1 by x to the power 4. So this is the required solution. That's how we can solve such kind of equation. So hope you have understood. And if you like the video, then hit the thumbs up button and share with your friends and subscribe the channel. And if you have any doubts and if you have any questions regarding this topic, you can comment. You can ask me in the comment box. I will provide the my Insta ID. There you can post the, just simply click the question, take the photo of question and send me there, then I will try to solve that. So thank you for watching. Please subscribe the channel if you are new to my channel. Thank you.